Hello and welcome all to section 3, which is IPv4 classes. This is video 6 section 3 lecture 1, in which we will study about calculation of first octet values for the different classes of IPv4. Before starting with those calculations, let us have a quick review of what we have studied in section 2. In section 2 we studied binary number system, which consists of zeros and ones. It is considered to be computer's native language. IPv4 is a 32-bit system, that is IPv4 is divided into 32 bits. These 32 bits are further divided into 4 blocks. Each block is called an octet and each octet is 8 bits long. Then we saw how to convert binary to decimal. We also saw how to convert decimal to binary. We know how to find the different exponential values of 2 from index 0 through 32. We went as high as 32 because this is a 32-bit system. Make sure that you know the values 2 power 0 through 2 power 16, then 2 power 24 and the last value 2 power 32, because these are important values, and if you remember these values your calculation becomes a lot quicker. IPv4 is divided into 5 different classes, and these classes are class A, class B, class C, class D and class E, of which class E is reserved for special purpose or it is reserved for future use. Class D is for multicasts and it is used by dynamic routing protocols such as RIP, OSPF, EIGRP, ISIS, etc. So we are going to study only about class A, B and C. Let us see what is the structure of these three classes. Class A has got a structure of network, host, host, host. It means the first block is for network and the remaining 3 blocks are for hosts. Or we can say that the first 8 bits are for network portion and the last 24 bits are for the host portion. Likewise in class B, the first 16 bits are for network portion, whereas the remaining 16 bits are for the host portion. Similarly for class C, the first 24 bits are for the network portion and the last 8 bits are for the host portion. Now there is a formula given by IANA, or the computer engineers or the computer scientists, for the hierarchical division of IPv4. Now this formula says that for any IPv4 address to be in class A, the first bit has to be 0. For it to be belonging to class B, the first 2 bits must be 10. Likewise for class C, the rule is the first 3 bits must be 110. Now let us understand how it comes. 0, 1 comes and pushes it and it becomes 10. Then another 1 comes and pushes this and it becomes 110. Very easy to remember. No rocket science. Okay, now let us do the calculations for the range of class A first octet values. So to find the range we need to have a minimum value and a maximum value. The rule says that the first bit must be 0 and all bits cannot be 0. So if we combine these two rules, then the first bit is 0 and all bits cannot be 0. So to get the minimum I have to turn the last bit 1, because the last bit has a decimal value of 1 and the second last bit from the right side has got a decimal value of 2. So 1 is the minimum value. So this is the new binary value. Now when we convert this binary into decimal, this becomes decimal 1. Likewise to find the maximum value we have to turn the remaining 7 bits on, because we get the maximum out of it. This 0 is according to the rule. Now this is the new binary. When we convert this binary into decimal, it becomes 127. So we can say that class A range is from 1 to 127. But 127 is reserved for loopback address for the NIC, which is network interface card. Network interface card is required for networking or browsing the internet. So class A first octet decimal value is in the range 1 through 126, both inclusive. So if we ever see a IPv4 address starting with this range, then we can say that this particular IPv4 address belongs to class A. Let us see class B. So for class B, the first 2 bits must be 10. So to get the minimum value, we turn the remaining bits off, and to get the maximum value, we turn the remaining bits on. So this comes to 128 and this comes to 191. So we can say that class B first octet decimal value is in the range 128 through 191 both inclusive. So if we see an IPv4 address which starts with this range, then we can say that this particular IPv4 address belongs to class B. For class C, the first 3 bits must be 110. To get the minimum value, turn remaining bits off, and to get the maximum value, turn the remaining bits on. So this gives us a range of 192 through 223. So if we see an IPv4 address starting with this range, then we can say that it belongs to class C of IPv4. This is not required, but I am just giving it. The first 4 bits must be 1110. So to get the minimum, turn the remaining bits zeros. To get the maximum, turn the remaining bits on. And this gives a range 224 through 239. Likewise, for class E, the range comes 240 through 255. We don't need to remember this. As class E is reserved, we do not guess or assume its rule to be 11110 as we have seen earlier in the first 5 bits. So we leave its calculation. Moreover, it's reserved and not in use for us. It may be for some special purpose, who knows. So let us just remember these 4 classes. The range is for class A 1 through 126. For class B, the range is 128 through 191. For class C, it is 192 through 223, and for class D it is 224 through 239. What about the other octets or the other blocks? The other blocks can have any value. Minimum 0, maximum 255. That should be it for this particular lecture. So thank you very much for listening to the video. See you in the next lecture. Thank you. Bye until then.